Hey guys, Mr. Mackey here. Now yesterday I showed you how to solve simultaneous equations and how we have to make sure the coefficients of either the x or the y are the same in both of them. And I set you this challenge where you might have to change more than just one of the simultaneous equations to get a same coefficient. So I have 3x plus 4y equals 22 and 2x plus 3y equals 16. Obviously we can't multiply the 2 by a whole number to get to 3, and we can't multiply the 3 by a whole number to get to 4. So we're going to have to multiply them both by the lowest common by the best factor that works. So for this one, I'm going to do it to the x's. So what can we change 3 into and what can we change 2 into to make them the same? Well, we have to choose 6. So what I'm going to do is I'm going to draw a little arrow. I'm going to change it so it goes over here. For this, we need to multiply our 3 by 2 to get to 6. I'm going to write 6x. For this, we need to change our 4 multiplied by 2, so it becomes 8y. And we multiply that by 2, so it becomes 44. For the one down here, to turn that 2 into a 6, we multiply it by 3. To turn that into 2, we multiply it by 3 and by 3. So that becomes 6x plus 9y equals 48. Now that we've done that, we can now get rid of one of our coefficients. Now I'm going to get rid of the x in this one. So we're going to do some subtraction. So 6x take away 6x is 0. 8y take away 9y is negative y. And 44 take away 48 is negative 4. So if negative y equals negative 4, then y will equal 4. Now that we know this, we can find out what our x is. So we'll do it for the top one. So 3x plus 4y equals 22, but we know what our y is. So we do 4 times that y. So 4 times 4 is 16, so it's actually 3x plus 16 equaling 22. Let's do a bit of balancing, take away 16 on both sides, so it becomes 3x equals 6. And then by balancing again, we'll get our x value, which is 2. Now we're still going to focus on simultaneous equations today, but we're going to focus on a little bit different, with a different method and a different circumstance. Let's see what I mean. Now I've got a simultaneous equation, but this time one of the equations is quadratic. X squared plus y squared equals 5. Now I'm going to solve this simultaneous equation by substituting this equation into that equation. You're probably wondering what on earth I mean. Well, hear me out. What I'm first going to do is I'm going to put y on one side of this equation and x on the other, and that is by balancing. So what I'll do is I'll rub this out, and when I balance it, I'll be adding x on both sides, so y would be x plus 1. That's what you get by balancing it out. Now that I've got them all on one side and I know y equals x plus 1, I can replace that y squared with this value squared. So let me show you what I mean. So I'm going to rewrite this equation underneath. So x squared plus x plus 1 squared equals 5, because I am squaring it. Does that make sense? So now I'm going to do the x squared here, and I'm going to expand these brackets. Do you remember how we expand it? We did it in the previous algebra week. So you have the x plus 1 and the x plus 1. That'll become x squared plus 2x plus 1 equaling 5. Now, let's tidy this up a little bit. This becomes 2x squared plus 2x. And I want to move everything to one side so it all equals 0, so it's easier to factorise. So we take away 5 on both sides, so 1 take away 5 becomes negative 4. So now I've done this, I can factorise a lot easier. But I can get rid of that too, because all of these have an even number. I can get rid of them, I can divide it by 2, so it's a bit tidier. So I'm going to move up here. 2x squared plus 2x plus 4 is the same as x squared plus x minus 2. Equaling 0. So let's factorise. What do we multiply together to get negative 2 but add together to get 1? X plus 2 and x minus 1. So Because we have a quadratic equation in one of our simultaneous equations, that means that we will have two values for x and two values for y. So our x could either be -2 or 1. Now from this, how can we find our y value? Well, we just put that back in the original problem. So instead of -2, we substitute it in, so -2 squared becomes 4. 4 plus y squared equals 5. So we balance on both sides, so y squared equals 1. That means y would equal 1. We do the same for this. We substitute it, and so y would become 2. However, when we square root our y, when I wrote 1 and 2, it could be -1 or -2, because remember, when you square things, it could be one or the other. So I'm actually going to put plus or minus 1 and plus or minus 2, because it means it could be either of those. While we know what our x values are, because we have done it through factorising, the y ones are still subject to debate. It's tricky to grasp, but all you need to know is that whenever we're square rooting, there's always two values we take into account. In this case, we have a -1 and a +1, and -2 and +2. It is tricky, but let's do another one and let's see how you do. Let's do it to this one, and then I'll let you have a challenge. So x squared plus y squared equals 1, x plus y equals 3. The first thing we have to do is balance the equation underneath out, so x on one side and y's on the other. Now this, you could either subtract x on both sides or subtract y on both sides. Because I did it with x before, I'm going to do it for y this time. So I'm going to make it so it becomes x equals 3 minus y. Because we're subtracting it, it's only easy to lay it out. The next thing we need to do is substitute that into the equation above. So I'm going to write it. So I'm going to put 3 minus y squared plus that y squared equals 1. So now I'm going to expand this 3 minus y squared brackets. So it becomes y squared minus 6y plus 9 plus the y squared from earlier equals 1. So how is this going to look? So we add the two y squareds together, so that becomes 2y squared minus 6y plus 9 take away 1, that becomes plus 8 equaling 0. Because that's all even, I can get rid of some of them. So that becomes, I'm going to move up here, y squared minus 3y plus 4 equaling 0. Now I can factorise this. So it becomes y -4 and y plus 1. And from that we can work out our two y values. They're either -1 or 4. Now from this we can substitute our x's into this problem. So we have x squared plus y squared, but our y is 1, so it's x squared plus 1 equals 1. But the problem is, there's nothing for x. So that means our x in this one is 0. For this one we have y equals 4, so we substitute that, so it becomes 16. Subtract on both sides, so x squared equals -15. What will that get you when you enter it in a calculator? You get a math error, don't you? That's because there is no value when you root a negative number. It's impossible. It's mathematically impossible. So this coordinate with the 4 doesn't actually exist. It's an impossible one. So there's only one coordinate, one possible answer we can get from this, and that is our x equaling 0 and our y equaling -1. See, even if there's a quadratic equation, it doesn't always mean there's two answers or coordinates to choose from. You just need to think about it carefully. Now, let's move on to a challenge. So here is your challenge for today. Here's two simultaneous equations. Let's see how you do. Now, I will give you this. You won't get a whole number when doing this. But you will get a number, but it won't be an imaginary number. It won't be impossible, let's just say that. And you might need to use more than just factorising to solve this equation. Think about a certain formula in quadratics that will help you. Good luck, guys. I'm looking forward to seeing what answers you got. Take care.